Sinusoidal functions and math models. So I hope that, let me invite Rubio in here. There you go, Rubio. No, we're good, miss, we're good. So here we go. Example 1. Suppose that a water wheel, and I hope that you guys know what a water wheel is. If you don't, go to Google and type in water wheel, and you can see what it is. In the figure to the left, rotates at 6 revolutions per minute. So 6 revolutions per minute, that might be important info. Maybe underline it. 2 seconds after you start a stopwatch, point P is this one here in red now, is on the rim of the wheel, and its greatest height is at 13 feet above the surface of the water. The center of the water wheel is 6 feet above the surface. Okay, I think we understand what's going on. Reread it one more time if you don't understand the situation. And letter A says, sketch the graph of D as a function of time T in seconds since you started the stopwatch. All right, so I'm gonna sketch a graph. I'm gonna go ahead and make the y-axis, and I'm gonna call this the d-axis, which is the y-axis. And then the time is always independent. So notice that I'm putting the time a little lower. I'm not kind of putting it there in the middle. And this is gonna be the time axis. The T came out a little low there. Sorry guys, I'm noticing that I'm gonna need some calibration pretty soon because it doesn't seem to be writing exactly where I wanted it to be. It's a little off, so maybe I need to put another pick or something. All right, so here we go. So it wants me to sketch, and it says sketch the graph D, and D is how high this point is with respect to the water surface. So I know that the highest this point is way up here, and that is that 7 plus 6, so that's a 13. So that's gonna be my high point. So I'm gonna go up here at the high point, and I'm gonna put 13, and this is gonna be in meters. You don't have to do the sound effect. And then I know my low point is way down here, and that's gonna be at, let's see, if this is 6 feet and the radius is 7 feet, then that's gonna be at -1. So it's gonna be 1 foot below the water surface. So I'm gonna say 1 foot below the water surface. I'm gonna say it's right there. And it's obviously not to scale because if this is 1, then that 13 should be way above. And the middle, I'm gonna say the middle is right here, or the midline, and that's gonna have to be 6. And I'm going slow, guys, so you guys can draw. It doesn't have to be perfect. You ready, Rubio? All right, Rubio's ready, so that means we gotta keep going. So now it says, let's see, 2 seconds after you start the stopwatch, point P on the rim of the wheel that its greatest height 13. So 2 seconds, I'm gonna say 2 seconds is right here, guys. And at 2 seconds, I'm at the greatest height 13, so put a point at 213. I know that this water wheel does 6 revolutions every minute. So if it does 6 revolutions every minute, how long does it take for me to do 1 revolution? Yeah, how'd you figure that out, Rubio? Oh, how'd you figure that out, Uncle Seb? Perfect. There are 60 seconds in a minute. You're doing 6 revolutions a minute. So that means it goes perfect for 1 revolution every 10 seconds, guys. So if I'm doing a complete revolution every 10 seconds, that means at 12, I'm gonna be at another high point. So I'm gonna say 12 is right there, and I'm gonna put a high point right there, guys, at 12:13. So put a point at 12:13. Try to keep the gaps the same, guys. I'm gonna go to 22, and again, 22:13. And one more just for kicks. 32:13. And if you want to get ahead of me, you can, guys. You can already see where we're going with this. If it takes 10 seconds to reach the high point or to do a complete revolution, I know 5 seconds later, I've done half a revolution. So 5 seconds later, from the high point. So 5 seconds from the high point, I know that I'm at a low point. Does that make sense? So 5 plus 2 is 7. So I'm going to say 7 is right there. So at 7, put a point on -1. And I'll just repeat every 10 seconds. At 17, put a point at -1. At 27, put a point at -1. And I can see that I wonder why my digitizer is working weird. Yeah, I don't know. Maybe I'm running out of ink or something. So there it is, guys. And we should try to make points of inflection perfectly in the middle between your high and the low. You don't have to be crazy accurate, but try. And then just put little bowls in the top and the bottom. Yeah, I should have restarted my laptop because I can tell that something's fishy. Fishy, where this is a water wheel. Oh, okay. All right, it's not funny because we're not doing a fish problem. But if you've ever drawn digital, like on a digital platform, and imagine that you draw something on the laptop or a digital on some type of digital device, but it's off ever so slightly. Like you write something, and then every time you write, it's not perfect. It's like a centimeter or a millimeter away from the tip. So having that type of discrepancy, it's kind of annoying when I'm writing here or drawing. So that's why my drawing is not going to be perfect. And I don't know. I think it might be a digitizer issue. So well, hopefully it is. We'll find out. All right, there's my drawing. It's not perfect. There's some issues, but for the most part, it looks okay, I guess. Um, yeah, I mean, these points don't really look like very good points of inflection. Uh, I mean, that one looks really bad, but that's fine. It's a good sketch. Hey, no one fall asleep. You heard me, Rubio. Any questions right now, virtual class?
Yeah, just like really quick. What are the numbers on the x axis?
On the t-axis? You can say x-axis. I'm just being specific here. The first high point is at 2. Man, look, my digitizer doesn't even. This is a 2. And then this one's a 7, the low point. And then this one's a 12, the high point. And then there's a 17, the low point. And then a 22, and then 27, and then 32, and then 37. It did that without a problem. Okay, here we go. It says letter B, assuming that D is a sinusoidal function of t, write a particular equation confirming or confirmed by graphing that the equation gives you the graph you sketched in part A. Okay, so instead of doing this, guys, y equals a cosine b x minus c close plus d. Instead of doing that, we're going to do d equals a cosine b t minus c close plus d. It's the same. The only difference is we're changing our x-axis and y-axis to t and d. So here we go. D equals the amplitude, the gap between 13 and 6, that's a 7. So I write 7. And you actually could use sine because we actually do know our points of inflection, like we do know them. But it's always easier to use a peak, so we're going to use cosine. So I'm going to write cosine, and as you can see, my digitizer is writing funny. Cosine, and then I need the b value. So the b value is 2 pi divided by period. The period is 10. So the b value is pi over 5. So I write pi over 5, open parenthesis, and then I'm going to write a t value because it's a t-axis, minus, and then the first peak happens at 2. If you want to be different, you can write 12 or 22. Like, I don't want to conform to your math. I want to do my own math. Okay, good for you. Do it at 12 or 22 or whatever value you want. Plus your midline is 6. So there it is, guys. And it looks kind of funky. It kind of looks like a first grader, did this equation. But no, it was me. And it's just that my digitizer is just being funky. I see a lot of squigglies, like if my wrist doesn't stop shaking or something. I can assure you, I'm not shaking. There is a disease where you just constantly shake. I don't know what it's called, but I've seen it on like people that like are trying to eat. They can't, eat correctly because their wrist is constantly moving. But anyways, uh, you guys are gonna make their life better by creating super awesome spoons and robots and all that good stuff for them, because you guys are the future. So we're teaching you the math that's necessary to do all that good stuff. All right, guys. Next, oh, it says confirm, right? We haven't confirmed anything. So let's confirm it. I'm gonna go to Desmos because Desmos is the best tool right now. So we're gonna take out Desmos and we're gonna see what's up. So I'm gonna click share and I'm gonna click Google here. And so there it is. And then I click Desmos and I definitely want a graphing calculator. So in here, you can actually use letters like D if you wanted to, but I'm gonna stick to Y equals because that way we don't have to program anything. Y equals, and I wanna say the amplitude was 7, and then we use cosine. Where are you, cosine? And what was it be? Pi over 5? Pi over 5, and then move that to the right. And then it was X or T minus something. 2. So 2, close, and then it was plus 6. Boom. And there it is, guys. Click on this little wrench. I mean, you can always like fix it, but I'm gonna click on the little wrench here. And I'm just gonna go, let's see, let's start from -2. I mean, there's no such thing as negative time, but negative numbers do mean something. 2 seconds before you started your stopwatch, I guess. And I'm gonna go to 30. And y-axis, well, let's see, I'm gonna go to -2 or -3. And then the highest I go is 13, so I'm gonna go maybe to 18. And there's my graph, guys. And let's check to see if we're correct. At 2, I better have a high point. So I click on the high point there, and yep, 213. So I'm gonna go to 12, and I'm gonna see if I have another high point there. And I do. There it is, 1213. I'm gonna go to the min point, and I'm gonna click, and there it is, 7, -1. 7, -1 is in the lowest. So I'm good, guys. Yay, let's go back. Was that fun or what? What do you think, Ms. Jacobs? Are you having a good time?
Yes, sir.
Okay. So maybe on the next time that you guys go all out to eat as a family, like any of you guys, maybe bring some of this with you guys and tell your parents, like, let's have a good time and do this together. Because it's kind of fun. Look, check it out. This is gonna be kind of fun. How high above or below the water surface will point P be at time t equals 17.5 seconds? At that time, will it be going up or down? Ooh, okay. Well, let's find out. I'm gonna go to Desmos, and yes, I can just go to 17.5, and I can see, if you look at my arrow here, I can see that at 17.5, it's somewhere between this low at 17 and that 18. I can see that I'm going up and that I am below the water surface, but let's make it more exciting. Let's get exact values. So check it out, guys. Usually you can type the word table in here and it'll come out, but because I have the laptop the way I have it configured right now, it's just easier to click on this button. And let me put a subscript down here. I'm gonna put y's of 1. Oh, I should put parentheses in terms of x. Okay, so there it is. So x and y's of 1 in terms of x. No, doesn't like it. It doesn't like it. Let me put f of x, guys. I don't know why it doesn't like it. F, and it's a function in terms of x. There we go. And let me clear this guy. And let's go ahead and, does it not like it? Oh, I gotta click on, maybe this was the issue the whole time. Yep, that was the issue the whole time. Man, I could have left it. I did all that for nothing. All right, anyways, at what time did I want it at? At 17 point what? I can just do this, guys, 17.5, boom. And look, it tells me. And I should have a point that's purple. This is probably blocking it. And look, there it is. My point that's purple. Isn't that awesome, guys? That is super cool. So it tells me that it says 0.657. Someone write that number down, negative 0.657. Put it somewhere on the side. And you can see, remember, you read a graph left to right. Left to right, point P is below the surface of the water at 0.657 feet or meters. I think it's meter. No, it was feet, I think. And it's on the way up. So that's what I'm going to write. So I'm going to come back. And it says, how high above or below the water surface will point P be at time 17.5? So I'm going to answer their question. I'm going to say at t equals 17.5 seconds, comma, point P is, and what were the depths? 0.657 or 675? 657 feet below the surface, period. Oh, they also wanted to know, is it going up or down? So I'm gonna reiterate, you know what? I'm gonna take away the period. And going up. Yay, now we're good. At t equals 17.5 seconds, point P is 0.657 feet below the surface and going up. The surface of what? The surface of water, or water surface, but that's fine. Yay or nay, guys? All right. Virtual class, yay or nay?
Yay.
Yay. Letter D. At what positive time t was point P first emerging from the water? Oh, no big deal. We can do that. Let's go to our Desmos. So I'm going to go to Desmos back. And we just look at our graph. Here's where I started at time 0. Point P went up, it went down. Here's when it first went into the water. I don't want that one. I want the one when it first emerges from the water. So I see that that t value looks like it's 7.861. So write that down, guys. So write it down somewhere, 7.861. And that's what I'm going to use. I'm going to come back and I'm going to say point P was first emerging from the water. Let's use chemistry. Everyone uses H2O. Let's change it up. HOH. Emerging from the water at t equals, and I already forgot the time. You guys hooked me up. 861 seconds. There it is, guys. A job well done. All right, let's keep going. We got one more. You guys are gonna like this one because first period, they said this was the best question they've ever done and seen. And they don't want to do anything else but math and pre-cal, and that they wish they could just do this all day. And if first period said that, then I believe you guys are gonna love it. And actually, I don't think they said that, guys. I'm just making that up before first period comes over and starts beating me up. Example 2, it says, suppose you seek a treasure that is buried in the side of a mountain. The mountain range has a sinusoidal vertical cross section. Oh, that's pretty cool. The valley to the left is filled with water to a depth of 50 meters, and the top of the mountain is 150 meters above the water level. You set up an x-axis at water level and a y-axis 200 meters to the right of the deepest part of the water. Okay, that makes sense. The top of the mountain is at x equals 400 meters. And they give me a nice picture. They didn't have to give me a picture, but they did. And I thank you for drawing me a super beautiful picture. And then letter A says, find a particular equation expressing y for points on the surface of the mountain as a function of x. Okay, so what they want is, they want this equation for everything in red. So I have a mountain, and this mountain just so happens to look like a sinusoid. So let's go ahead and write this equation. So let's find out what A, B, C, and D are. If we're using cosine, you could use actually the 200 if you wanted to, the negative 200. But if you're using cosine, you want to use the peak. So I'm going to say that the C is 400 to the right. The midline, let's see, where's the midline? The midline is the middle between the high and the low. So 150 plus a negative 50, that's going to be 100. And then divide that by 2, that's going to be 50. So the midline is 50. And then the distance from 50 to 150, that's 100. So that's amplitude. And you can check it from 50 to negative 50, that's also 100. And then the B is 2 pi divided by the period. So let's see. I don't have a full cycle here. I have half a cycle. Now, I've seen this mistake. I saw this mistake on your homework, guys, and I put it in there. The difference between negative 200 and 400 is not 200. The difference between negative 200 and 400 is 600. Now, that's half of the period. So that means the whole period has to be 1,200 or 1,200. Does that make sense to everyone?
Yes.
Okay. So the B is pi over 600. I have everything I need. Here we go. Y equals, they told me to do it Y in terms of X, so I keep the Y and the X. Y equals 100 cosine pi over 600 X minus 400. Wow, now it's actually writing correctly, guys. I don't know what happened. What's the difference between 5 minutes ago and now? Plus 50. If you want to be unique and you're like, Chavez, I don't want to use that equation. I don't want to conform to the math that everyone else is doing. I want to do mine different. Fine, put X plus 200 in there and put a negative in front of the 100 and you can be different and still have the same correct answer. Does this make sense to everyone? Yeah, there's more than one way to do this stuff. I was gonna say to skin a cat, but why would anyone want to skin a cat? And where did that phrase even come from? There's more than one way to skin a cat. That's like, okay, I'm gonna stop, guys, because oh, you never heard that? Oh, okay. I don't know. Maybe it's an old person thing. But yeah, so there it is. And yeah, guys, I think we're good. I don't think they're asking for anything else. So you're probably wondering, like, man, Chavez, you said this is gonna be hard, but this is all easy. All right, you're right. Letter B. The treasure is located beneath the surface at the point 130, 40. Okay, let's put that point in here. Where it says treasure, put that dot in there and put 130, 40 somewhere. That's that point. That's where the treasure's at. That's shown in the figure to the top right corner. Whoa, what was that? It was not a fart. It was someone with a muffler or whatever. Anyways, which would be the shorter way to dig towards the treasure? A horizontal tunnel or a vertical tunnel? Show your work. All right. Let's see if we can understand what's going on here, guys. They want to know, and I'm going to go ahead and color code it. They want to know, is this shorter, what's in blue, the vertical tunnel, or is the green one shorter? Well, I don't know. It looks pretty close to me. They both look the same. So that's what that's what we want to know, guys. So here, let's go ahead and see if we can figure out a game plan. It's not hard to do. So if I want to figure out the vertical tunnel, all you got to do is figure out where you are at, the Y value of where you are at on that mountain. Does that make sense to everyone? And we can do that by plugging in an X value of 130. Then that's going to give us the Y value of the mountain. And then we can just subtract the Y values. I can subtract the Y value from the mountain to the treasure, the 40. And that will tell me how long that vertical displacement is. Does that make sense, virtual class? Uh-oh.
Yes.
Yes.
Okay, all right. So here we go. I take my equation. Y equals 100 cosine pi over 600. And what am I going to insert for X? The X value. 130 minus 400 plus 50. Don't worry. I know that we got a lot of visual people. So let me go ahead and erase the 130 and put X, and then I'm gonna write what we're doing. Insert X equals 130 to find Y value of mountain. All right, guys, you guys ready? I'm gonna go to Desmos for you visual learners. Here we go. I'm gonna erase this guy and put my new equation. So let's see what that equation is. I already forgot it. 100 cosine, and then it was pi over 600. And then open parenthesis, x minus 400, close, and then plus 50. All right, there it is. No, it's not linear. It's just that we're super zoomed in. Click on the little wrench. And let's see, let's go from negative 300. All I'm doing is going a little bit to the left of that drawing that I have there. And let's say that's 400. So let's go like to 600. And let's see, my depth, it's negative 50 is the lowest. So let's go to negative 75. And let's see, 150 is the highest or 100? I don't remember. 150, right? So let's go to 175. All right, there you are. And what's the point? The treasure is located at 130, comma 40. All right, where you see that point in red, that is where you are at. That's where the treasure's at. Okay, I want to know, I'm going to click 130 here. I want to see the Y value of where I'm at. So obviously it's getting this value because it's getting it from the old one. So I'm going to erase that 17.5 and I'm going to put 130. Boom, 130. You're right up there. So do you see how that little dot, you can see I can just draw a vertical tunnel there, and that difference is the length of the vertical tunnel. Do you guys see that? Perfect. Virtual class, are you guys okay with the logic so far?
Yes.
Perfect. So I take this value, what is that? 65.643. Make sure to write that down somewhere, guys, because I'm going to need it. And let's go and figure this out. So Y of 130 equals, and then you guys hook me up, 65 point what? 643. And this is in meters, I believe. Yep, meters. Okay, so vertical tunnel has to be, let me see, vertical tunnel will be, and in parentheses, I'm gonna write 65.643 minus 40 meters long. And then I'm gonna write vertical tunnel. I'm gonna put colons, and I'm just gonna subtract 40 from 65, 40, 50, 60. So it should be 25.643 meters. And I'm gonna put that there. All right, now I'm gonna do the one in green, the horizontal. I'll wait for you guys to catch up. Let me drink some water. Drink some water, guys, because water is good for you. Two hydrogens and an oxygen make a water. You guys know that, of course, because that's like baby stuff. What's the atomic mass of hydrogen? Oh no, what's the mole? Okay, never mind. Let's not talk. Do you guys remember? You guys remember like Avogadro's number and all that good stuff? 6.02 times 10 to the 23rd to get molarity, moles. Okay, make sure you know that. Oh, guys, oh, you're not in chemistry? Well, you'll learn it. It's cool stuff. I used to love chemistry. That was my favorite subject in high school. Yeah. You should take the chemistry AP exam. It's a fun exam. You'll actually be very entertained by it. All right, guys, here we go. Now we're doing the one in green. Sorry if I spoke about chemistry AP. I really love chemistry, guys. That was my favorite subject in high school because I had a super awesome chemistry teacher. I didn't get a 5 in the chemistry AP exam, guys. I should have. I felt like well, I don't know. I felt like I let my teacher down. I got a 4. But I should have gotten a 5 because I really loved chemistry. I enjoyed it a lot. Anyways, here we go. So what did I want? I wanted the horizontal distance. All right, game plan. How do I find the horizontal distance? Well, remember when you were in algebra 1 and algebra 2, Miss Torres would always be like 40 equals, yeah, because that's a y value. 40 equals 100 cosine pi over 600 x minus 400 close plus 50. And Ms. Torres will probably tell you, put this in y1, put this in y2, or f of 1, f of 2 in your TI Inspires, and find where they what? Intersect. And maybe you ask her like, Miss, I don't know why I'm doing this. Well, look, here's why you're doing it, guys. If I were to type in y1 equals 40, it will give me this line. And if it gives me that line, all I got to do is tell the calculator, give me that x coordinate. And if you give me that x coordinate, you just go 130 minus that x coordinate, and that will be the horizontal displacement of that tunnel. Does that make sense, guys? Now, it does say to show work. That's probably the way to not do much work, but I'm going to show you guys still anyways how to do it. So let's go ahead and first do this first with Desmos. I'm going to write Desmos, and I'm going to write 40 equals 100 cosine pi over 600 x minus 400 close plus 50. And from here, as long as I see that you wrote something like calculator or whatever, you can tell me what the answer is, what that x value is. Don't worry, we are going to show you how to do it algebraically. So here we go. I'm going to go to Desmos, and I'm just going to type in, I'm going to make another one, and I'm just going to go y equals 40. And check it out. There's my y equals 40 line. Beautiful, beautiful line. And then there's the intersection. I just click on it. Oh, look at that. It gives me an x value of where it intersects. What's that x value? 80.869. Write that down somewhere. So now I'm going to go back to my paper. And I'm going to write x equals 80.869. That is not the length of the horizontal tunnel. I got to subtract. Remember, the treasure is located at 130. So I got to subtract 130 minus that 80. And that's going to give me my horizontal displacement. I guess you could also reverse it. Just make sure that it's positive. So the absolute value or whatever. So here we go. I'm going to write horizontal tunnel will be, and then in parentheses, I'm going to write 130 minus 80.869 meters long. And let's see what that number is. 49.131. So horizontal tunnel, 49.131. I did it here offsite, guys. Meters long. Which one's the shorter tunnel? Vertical or horizontal? Vertical. Vertical is a lot shorter, guys. So somewhere here, I'm going to say, I'm probably going to circle vertical tunnel. That does not mean that you answered it. Tell me. Vertical tunnel is shorter. Vertical tunnel is shorter. If you want to be super cool, tell me by how much. But, it doesn't ask for that. Vertical tunnel is shorter. If the length of the tunnel is what we're worried about, like for money reasons, then vertical tunnel is the way to go. Of course, there's more variables. All right, guys, let me show you how you should really be doing it for those that want to see the work. So start with this equation. And what we're going to do is we're going to solve for x. So I'm going to write it right here. So I'm gonna scoot that right here. So here we go. 40 equals 100 cosine pi over 600 x minus 400 close plus 50. So I want to solve for x. That's all I'm doing. So the first thing we're going to do is we're going to move the 50. So minus 50 minus 50. So when I do that, you're going to have negative 10. I'm going to write the negative 10 on the right hand side, guys, because I like to have the x on the left hand side. So 100 cosine pi over 600 x minus 400 close equals negative 10. And then I want to get rid of the 100, so I'm going to divide by what? Not everyone at the same time, guys. Divide by 100, right? So I'm going to have cosine pi over 600 x minus 400 close equals a negative 1/10 when you reduce it. And now I want to get rid of the cosine, so I'm going to do arc cosine or inverse cosine. So I'm going to have pi over 600 x minus 400 equals plus minus arc cosine of negative 1/10 plus 2 pi n. And no, you're not going to add 2 pi n eventually. Well, the period is going to come out to 1200 n, which is the period. That should not surprise anyone. But you're not going to be adding anymore because the treasure is not repeating after every mountain. Now we're going to multiply by the reciprocal. So multiply by 600 over pi. So x minus 400 equals plus minus 600 over pi arc cosine of negative 1/10 plus the pi's cancel out. 600 times 2 is 1200. So 1200 n, that should not surprise you. And then finally move the 400 to the right. So x equals 400 plus minus 600 over pi arc cosine of negative 1/10 plus 1200 n. And really, the only one that matters is the minus, because the plus is going to take you out, like way out there. So let's see if we do the minus and see if we get, all I'm doing is this with the minus and see if and there's an n right here, but we don't need that. And see if we get that, what number? We're supposed to get this number right here. 80.869. Now, if we don't get it, that means I'm a fake. And I just taught you a whole bunch of math that doesn't make any sense, which we know that it's going to be true, right? Because we already did it. We did this earlier for first period. All right, so let's go ahead and back it up. Back. Oh, I don't want to go that far back. I don't want a graphing calculator. I want a scientific. What did I have? 400 minus our cosine. And what did I have? Oh, wait, I have something in the front. What did I have in the front? 600 over pi. Yeah, I think so. And then this was negative 1/10. I could also say 0.1. Change this to radians. And look at that, OMG, 80.869. Is that the same value we had earlier? Yeah. See how everything just works out, guys? Hopefully you're super pumped and super hyped and nowhere near wanting to fall asleep because you're just so excited about all this stuff that you're learning. All right, let's come back, guys.